As we all know that GnRH, it is created by hypothalamus. So GnRH neurons, they migrate from olfactory placode as early as 6 weeks to the medial basal nucleus of hypothalamus and line arcuate nucleus. Now this GnRH release, it is under inhibitory control during pre-puberty in females. So this inhibitory control is usually because of GABA neurotransmitters like GABA and neuropeptide Y. Around puberty, there is increase in kisspeptin secretion, and this kisspeptin, it acts on its receptor, which is GPR54, G protein coupled receptor 54, and cause release of GnRH. Okay, kisspeptin is known as gatekeeper of puberty. Now there is another this peptide which is known as neuropeptide Y, which is called neurobiologic brake. Why is it called neurobiologic brake? Is because in prepubertal girls, in absence of estrogen, it inhibits release of GnRH, but once there is estrogen production, then it facilitates GnRH release. Besides, GnRH is also under inhibitory effect of GABA and opioids. Okay, so this GnRH, once stimulated, now it has to release in pulses. As females approach towards puberty, first these pulses occur during night, but then these pulses also occur during day. Even when you administer GnRH exogenously, you have to give it in a pulsatile fashion. Continuous GnRH therapy can lead to depression of this GnRH neurons and decreased release of FSH and LH from anterior pituitary. This GnRH, it acts on the gonadotropes of anterior pituitary and cause release of FSH and LH. Again, the release of FSH and LH, it is pulsatile. It doesn't occur throughout the day. So this pulse frequency of FSH and LH, first of all FSH, it varies depending on the cycle, part of the cycle. Now menstrual cycle has follicular phase, it has ovulatory phase, it has luteal phase, and then there is luteal menstrual transition, luteal follicular transition. Okay, so in follicular phase, the frequency is 1 in 90 minutes, but this frequency, it increases around ovulation and becomes 1 in 60 minutes, and in luteal phase it is slower, that is 1 in 4 hours. So the purpose of increased FSH frequency in follicular phase is to create an FSH window. This FSH window means it keeps FSH in blood at a certain concentration and for a certain duration of time, so as to recruit a cohort of follicles from the primordial follicle pool. Now these follicles, the complement of follicles a female has, that is highest in utero, right? It is almost 6 to 7 million, and by birth almost it's 2 million. By puberty it's 4 lakh. Okay, by puberty it's 4 lakh, but those 4 lakh follicles, they are not going to ovulate. Only 400 are going to ovulate. Rest of the follicles undergo atresia. Now whenever there is a recruitment, whenever there is selection of follicles in each cycle, in a menstrual cycle, with the aim that one of it, at least one of it, should ovulate, it is known as recruitment. Now this follicular pool, in this follicular pool, there can be primordial follicle, there can be primary follicles, secondary follicles, then there can be preantral follicles, antral follicles, pre-ovulatory, and finally Graafian, which ovulates. So in the early states, these follicles, they are not responsive to FSH, so their growth is not FSH dependent. Okay, secondary follicle has receptors for FSH, so FSH can act only on secondary follicle. Okay, so thereafter the growth becomes follicle dependent. Also the preantral follicles, they secrete AMH. What is the purpose of this AMH? Is that it stops other follicles which are at a stage lesser than these follicles to enter in the process of recruitment. Okay, so in a way it doesn't allow all follicles to enter in the process of recruitment at a time. Besides, it also gives an idea of this follicular pool of ovary. Now the time which is required from primordial follicle to the formation of antral follicle, it's almost 85 days. Okay, so early stages of follicle, they are mainly FSH dependent. So once FSH acts on the follicle, it recruits them. So what are the signs of recruitment of follicle? Are there would be increase in the size of follicle, the flat epithelial layer, single layer which surrounds the follicle, that is converted to cuboidal layer, right? Also, there is increased gap junctions. The purpose of this gap junctions is to provide nutrition to the growing egg oocyte inside, okay, and other transmission of other signals, right? So this also, the maximum chances of a follicle to turn a dominant follicle is based upon the number of FSH receptors, okay.